Hello and welcome back. In this session, we are going to learn how to implement our own HashMap. Let's first go through the problem statement. Here we have the problem statement. Okay, maximizing it. Okay, let's read it. Design a HashMap without using any built-in hash table libraries. Okay, so that's basically we are creating uh, an equivalent of uh, Java Java's HashMap. Okay, and there are the things that we are supposed to design. Um, the design should include the following functions: put key value that inserts the key value pair into the HashMap, and if the value is already available, then it's going to update the value. And get key returns the value associated with that particular key. Remove key removes the mapping per the value key if that's available in the container. Okay, and then from line number 11 to line number 19 we have a typical test. Basically we create an instance of HashMap, we put two pairs with key and value same, and then we try to get, and for the first pair, since we inserted 5 5, it has written 5, and we have not inserted any key with 15, so it returns -1, it's returned -1. And we try to update the value with line number 16, so it will update the value for key 10, which is 10 before, with 5, and then we try to get that value, it returns 5. We remove that key value mapping, and next time we try to get the value, it returns -1. Okay, and there are a few other additional uh, requirements or kind of given information. All keys and values should be in the range of 0 to 1 after 6 zeros, which is basically, let's see what they say, it's up to million. That's actually million, 1 to million exactly. Okay, and then the number of operations should be in the range of 1 to 10,000, and then we're not allowed to use the built-in library. Okay, and then in terms of complexity analysis, we'll implement and we'll see. Basically, time complexity is order of n divided by k, where n is the number of all possible keys that can be inserted. So for us, given range is already 0 to 1 million all possible keys, and k is the n is the all possible keys, and k is the number of predefined buckets. So that will be, we'll just predefine it. And space complexity is order of k plus m. Again, the k is the number of predefined buckets in the HashMap, and then m is, let me scroll a little bit up here. Okay, and then have been inserted into the HashMap, and then okay, uh, and then okay, so I was going to read that. Okay, so key, so space complexity order of k plus m. So k is the number of predefined buckets. So we'll assign one particular number. En we mentioned that is the number of all possible keys, and we have the range there in line number 22. And m is the number of unique keys that have been inserted into the HashMap already, right? So that gives the space complexity. Okay, because the number of unique keys already inserted in HashMap, why that matters in terms of space complexity, that is, we will have to at least read them, right? Like in order to insert a new value, I cannot just insert. If I can just insert it, it's going to be order of 1, right? It's a constant because there is nothing, so I can just insert it. But that's not going to be the case, because if something is inserted, I'll have to check if it already exists. If it already exists, then I'm going to update. Otherwise, I'm going to insert. So maximum. In the worst case, how many times I need to I need to I need to do that is basically order of m for the unique keys actually. So basically, yeah. So that's that. In other words, we can tell that it takes that much space. K is the number of buckets. So how many buckets are there? So that's the additional space we are going to use. And then in each bucket we have the unique keys, right? So that's the total space required, and that's the additional space that we're going to use, right? Otherwise, the given input could be in the uh, that be the possibility is n. Possibility is n. All right, I think now let's go to implementation and it'll be more clear actually. In this particular session, we are not going to type the program because the program is a little bit longer, almost 100 lines of code. If we start typing, probably the size of the video will be bigger than I can upload in certain platforms. YouTube allows, I think, but the other platform that I'm going to upload does not allow larger video size beyond like 3 gigs, 4 gigs, something like that, maybe 2.5 or something like that. So I'm not going to take that risk. So, but I have already typed the program, so that's why we're going to go through the pre-typed program, but we'll run it. We've already seen in earlier videos how to program and how to do that. I'm going to activate this is the program. Okay, my HashMap app. I'm going to activate the line number so that when I speak, probably it'll be, when I speak, it'll be clear. All right, so we're going to do top to bottom actually. Hopefully it makes sense. But I'm going to explain it because I just finished typing it. So, okay, very quickly. In the line number 1, 2, 3, we're importing certain things that we are going to use. See, we are not allowed to use HashMap, Java util HashMap or Java util map, anything like that, because we're going to build it. We are doing an exercise to create create a HashMap ourselves, develop the API, And this is very interesting question because one of the finest companies, I'm again going to repeat that, Google, if you are doing interview, this question is very likely questions because they would like us to design and implement a particular hash map. And there is a valid reason for that because this is probably one of the best performing data structure that computer scientists have discovered so far, right? So that is a very good and very valid reason, and it's a good idea to actually practice this again and again. As you can see that I myself is not like too, I'm still clarifying certain concepts, because it's my first pass. So yes, we'll keep on practicing this until we become perfect, and we make interviewers happy. All right, line 1 to 3, we're going to make it a linked list because in the hash map inside we can use the linked list. So that those linked list is the interface. Both are in the Java util package, and we're going to make it an array list as well. Okay, so those are the 3 things that we are using from the library. All right, so we need in order to represent the key value, that's a pair. So we create a class called pair. That's our class, our name, and it has generic some type there, kv. We just name them kv so that we have type k, type b, because we do not know what's going to come in the hash map because it's a generic, so it doesn't have to be specific predefined type. Like I could say integer. If I say here instead of k and v integer, and I limit my hash map for integer only, right? Key also has to be integer, value also has to be integer. Okay, but I don't want to limit that. It has to be generic. As is Java HashMap, right? Java HashMap is generic. I can insert whatever I like to insert, right? So that's exactly what we're going to make it. So k is just a type, any type that can come. B is another type that can come, and I have this name first and second, right? So constructor, when we create a constructor, it just assigns the value first and second to value first and second of this class, right? Very straightforward, but just remember the generic, and that's exactly I think what interviewers also would like to see. They like the generic. That certainly is going to add. And next class is the bucket, because since bucket is the important thing, we're going to have n number of buckets. Obviously we specify that predefined value, but that's the important thing, because we in HashMap the concept is we find the right bucket and then we insert the value in that bucket, right? So bucket structure. So bucket, we have a, what do we have in the bucket? List of pair of integer. So here I'm fixing it. Okay, let's list a pair of integer bucket, right. I'm going to do work with the integers. I could also change that. I could also make it some other types, my custom design type or anything, any object, any value Java object. Okay, I can do that. So for this, yeah, let's do that. So I have a constructor, this bucket, and in my constructor I just create a linked list. I'm going to use that linked list internally while creating my HashMap. And then in the next one I have a get. I'm going to use all of this, all of this implementation later. Okay, that's why. So get is basically I pass the key and then I get the value. So you see, we have to check whether that is already well, that exists, because in order to get the value, the key should be already existing, otherwise we're going to get empty. But if we do that, if we get the empty, we get return -1 here in line of 27. If we get the value, we iterate. That's the type pair. This pair over here is the type, and it's a pair of integer, and this is the listed bucket is basically a linked list. Okay, in this linked list we check pair dot first, because pair it will have first and second. First equals key, passed key, then that means we return the pair dot second, the second value. We found it, we return the value corresponding to that key, otherwise we return -1. Okay, and then in the update, similarly, update also first we we have initial value of found is equal to false, because somewhere will well, somewhere is not too far. Here we in line with 35 we're setting it to true, but in order to set that true we have to find it first, right? Same logic in the array list, sorry, a linked list. We're going to iterate the linked list, and then we're going to test whether we find the key. Okay, and if we find the key, then pair the second is equal to value, right? And found is equal to true. And then if not found, then what do we do? If we find, then we don't have to do anything. We were not updating, right? It is there. We didn't have to update. We didn't have to do anything. So we first check that whether if it exists. If it doesn't exist, then we're going to add it, right? This dot bucket dot add, and then we're creating a new pair, and we pass the value key value, right? Okay, so instead of this integer, I could pass some other values also. Okay, I could make all generics, everything generics. I could do that, but I think this is more specific here. Well, if I want to remove it, also I need to again locate it. Okay, again I'm traversing through that linked list, and then if I find it, if key exists, then what do I do? From that linked list, I'm going to remove that. If that linked list has this remove available already. Okay, I'm going to remove that pair, and I just come out of the loop. That's it. Okay, so we have this implementation. We're going to call that. How do we call that? Okay, in my HashMap now another class here. I have a key space. Remember the key space. We have predefined key space. Let's go back and see. Where is it? Key and value should be within the range. That's the key, and that's the space for both key and value. Actually, number of operations should be in the range of this one. Okay, so we just certain things which we are making just assumptions. Okay, key space, we have one variable, another is a hash table. Okay, that's what we implementing, right? Hash table is the one we will be storing, retrieving. That's our final one. Okay, so in my hash map, I have one predefined value assigned to the key space. Okay, 2069, and my hash table is a new array list of bucket. You see that bucket, the bucket class remove. It has all remove, update, get, all of those, and then that makes use a pair class, right? Bucket is, the bucket contains pair of things, right? In its actually the bucket itself is like a portion of the hash table, okay? Or you could say hash map because of my hash map, right? So inside my hash map we have the hash table, right? So so what we do is we create the buckets from 0 to this key space. See, that key space we define here 2069. So we have 2069 2069 number of buckets. Okay, that's the bucket upper. So we are creating those many buckets here. Add new bucket those many times. So in my hash table I have 2069. Well, is it less? Yeah, is it less? 2069, exactly 2069 buckets. Okay, that's cool. Now it's a put. When I call put, well, I pass key and value. I want to insert. So, and I create the hash. See, hash key. I first create one. How do I do that? Whatever key is being passed, I divide that with the key space. Okay, what is the key space? 2069. So I have those number of buckets, right? So, and then that remainder gives me the hash key actually. Okay, hash key. Basically, what hash key gives me is that bucket identity, the level for the bucket. Okay, this hash table dot get. So because hash table contains the buckets, all those 2069 buckets, and then get this hash key, right? That means I'm getting first I'm getting the bucket, and in that bucket I'm updating with the key value and update. You know, if it doesn't exist, you'll insert. If it already exists, it doesn't do anything because we already implemented that. Okay, that's the API that's available in the bucket, right? Next we want to get. Get also, what do we need? We always need this hash key because I want to first locate. I need to first. I should be able to first locate the bucket, and I get the hash key by again doing the same operation, key divide, key mode the remainder this key space. And once I look at the bucket, what do? I do this hash table dot get hash key. That gives me the bucket identity. I go to that bucket, and then I in that bucket I get key, and that gives me the value. Okay, that's how I get the value using get. Last one is the remove. Okay, so remove, what do? I pass the key and then I remove that mapping of the key value, right? So again I need the bucket, right? So as key mode, this key space. So that gives me the bucket, right? Bucket, because there are 2069 buckets. I go to that bucket using the hash table dot get key hash key. Now once I have the bucket, I have basically each bucket has the remove method. So I can call the remove method and pass key, and then it removes that mapping, that mapping, right, from the linked list. Because the bucket, if you see, if you go up and see bucket, bucket is a has a linked list. You see, uh, list of, yeah, basically list of pair of integer, right, bunch of list. And inside, if you see line number 19, we have new linked list, right? So it's a linked list. All right, so yeah, so we completed operation in the my HashMap, a little bit below. Yeah, all of this we completed. Now final, the testing is done using the my HashMap app. Okay, I have a main method here, and then I create a instance of my HashMap. That's my actually HashMap. I insert 5 5, I insert 10 10. Key is also 5 for the for line number 84. Value is also 5, and for line number 85 key is 10, value is 10. And then I try to print what? Get 5, hashmap.get 5. So that means key is 5, so I should get value 5 for this line. Okay, remember value 5. And then for 15, it doesn't have any key with 15, so it doesn't, it returns -1. And then I insert for key 5, I supply value, sorry, for key 10 I supply value 5, and that means pre-existing is 10 10 is going to update the value for the key 10 as a 5 instead of 10, because already existing is 10. Now it's going to replace that 10 with 5. Okay, so if I try to retrieve that, now I get 5 instead of 10. Okay, and then I remove that mapping, that 10 5 mapping, and then next time if I try to get value for 10, I should get -1. Okay, So that's the implementation. It's a long program, so we had a pre-typed program, right? So that I could save space, not space. Sorry, the timing for the video, but the space is true because if it is a larger video size, then I can upload it. Anyway, I'm gonna quit this and let's compile it just to make sure that it is working, because that's the program that we just saw, right? Compile that. Okay, no error. That's good. And now we're going to run it. And we already walked through the program, and we also expected what's going to be the output. Okay, we're expecting, I think, maybe 1 or 2, -1, because we first remember the 15 key does not exist, so that is -1. And next time we remove the key 10, and which had a value 5. We had updated that, and once we remove, we also get -1. And then initially we insert 2 key value pair, 5 5 10 10. Okay, so tentatively you got the idea basically. Okay, my HashMap app, that's it. You see, 5 -1 5 -1. Okay, let's go back to the program one more time. I just want to scroll through the program one more time, so that if you missed earlier this thing scrolling, probably you can just see it one more time when you're typing. Okay, you type this thing. Okay, we have import, we have pair class, we have bucket class. Okay, so you can see that. You can stop the video and then you can type if you want to practice. Okay, now I'm going to stop here at this point one more time from line number 30. Okay, I see we have update, we have remove, that's for the bucket class. Okay, and then I'm going to stop here for the my HashMap class. Okay, my HashMap has a key space, hash table as a field, and then we have constructor, it creates array list, and then we have put get remove method, exactly what is needed in the here in the description. Let's say here, if you see that's our requirement, right? We are implementing as something equivalent to Java's HashMap. And let me scroll down and show you the application, which is straightforward, a typical unit testing using main method, right? So this completes our implementation of HashMap API using Java. So in the next video, we'll do the same thing using Python. All right, this is the end of this video.